I would like to consider some new ideas on mathematical education with artificial intelligence support. The sustainability of our complex world lies in the possibility of creative potential developing of each individual and especially of schoolboy. In reality, we can be achieved in symbiosis of two factors interactions, development of complex systems and knowledge, and the introduction of artificial intelligence into the learning process. Problem: what kind of school mathematics and management methods of its organization, including intellectual systems, lead to each student's self-organization and creative potential growth? Aims to develop a technology for intelligent management of each student's research activities on the base, to develop the heuristical contents of complex knowledge and generalized constructs with the manifestation of synergetic effects, and to deploy each student's individual educational roles in an enriched information and educational environment. The main objectives are to determine the methodology, parameters and functionality of hybrid intellectual system support for each student's research activities, self-organization and the creative potential growth. The second, to define hybrid neural networks as an effective tool for solving complex multi-component, multifunctional tasks. And the third, to develop of students mathematical and computer modeling of complex knowledge generalized construct adaptation for each student. And the last, and using the dynamic level random sampling of contents, tools and instruments. The methodology of an intelligent system introduced into the project organization of each student's research achievements are based on third positions, first personal activity and synergetic approaches. The second concept of founding and personal experience in the condition of uncertainty. And the third, actualization of the phenomenon of complex knowledge in solving of purely structured tasks. The basic idea is visibility of mathematical and computer modeling symbiosis in the study of multi-state mathematical and information tasks with expert system using an hybrid intellectual system support. And trends of developing paradigm are personality in zones of immediate development, Vygotsky, the study of founding of generalized constructs of computer knowledge, Shadrikov, and person self-development and creative potential growth concerned with Morin, Mainzer. In this slide, the first stage of depository of modern achievements in science as a model of complex systems and knowledge. We have to show the importance of mathematics in real life, technique and economics. The exploding demand of modern mathematical achievements and achievements of fractal geometry, Mandelbrot, Kranover, Falkover, Barnslow, and House and catastrophe theory, Kolmogorov, Arnold, Tom, coding and exception theories, Shannon, Hamming, Huffman, Hill, fuzzy sets and fuzzy logic, Zade, Kaufman, theories of cellular automata, and Newman, Wiener, Conway, and others. And fractals, Mengers, Sponge, Sierpinski, Nepkin, Koch, Snowflake, Mandelbrot, and Julia sets. You can see on this slide. And the second slide, it is Benoit Mandelbrot with his presentation on Mathematical Congress in Madrid. The first, it is invariance of the lungs of a man. The second is with Salvador Dali and Sierpinski triangle. And the third, invariative of financial prices in economics. And the next slide is very important because very interesting situation. The example of Barnsley and Sikovanov. We have 6 linear transformations of a square on the plane. And let's find the mathematical expression and start the interactive process with computer modeling. After 6 iterations, we get an image of a maple leaf. And the next slide is Schwarz cylinder of as a complex knowledge. Perhus script slide, and the Sierpinski triangle slide, and the strange Lorentz attractor in this picture. And the stage 2, opportunities and functionality of students' research activity support by hybrid neural network. In this slide we have characteristic classifications and diagnostic of students' creative potential parameters. The first, it's 9 creativity parameters: modeling and integration of knowledge, reflection, flexibility and information saturation, supra-situational activity, logical acts, design and research activity, and others. The second, it's we should know that each parameter has 3 levels of presentation: low, medium, and high. And the third, the and set of possible basic variants is divided into 5 clusters of personal modalities: science, symbolic, figurative geometric, verbal, digital, and visual genetic. So we will have not more than 20 basic positions for every cluster. In the future, we must have 5 neural networks over the dynamics of each student's creative potential deployment. And the next slide we can see dynamics of parameters variation and success levels and research activity quality in the layers of hybrid neural network. And input layer you can see of criterion parameters, 9 parameters of scientific potential, and the output layer, it is classification of the levels of success and quality and the subject's research activity, and levels of scientific potential, 4 levels, and some support of expert systems. And typology of project levels and students' research activity. At last picture, you can see first search and productive, second empirical, third theoretical, and fourth creative stage. And should be create also the hierarchical subtasks tree of research tasks found in clusters. And the next stage is personal adaptive. First, choice and design and research activities implementation of individual educational trajectory. Second, implementation of each student personal preferences in the development of learning mathematics through a concise choice of research tasks found in clusters. And the third, experience and effectiveness of scientific activity field and dialogue culture. And in this slide, you can see the complex knowledge of founding cluster. And founding cluster at first stages of essence complex knowledge generalized constructs. Stage 1, it is initial level. Stage 2, functional awareness and correction. Stage 3, operational stage of awareness and generalization. Stage 4, evaluation of empirical verification of results. And stage 5 is integrative. And the next, pedagogical and expert systems support. It's database and knowledge of project activity topics in the form of subtasks, hierarchical tree of research tasks found in clusters, The second, instructions and rules of project mastering of research activities, and databases and knowledge of information support unit, mastering quality on scientific research methodology, computer algebra and dynamics geometry systems, as an identification and effectiveness of mathematical procedures and adaptation stages, and mathematical education synergy. And the third, architecture, parameters and functionality of neural network, and some positions concerning with individual creativity diagnostic, output law and free hidden laws on neurons, falsification of input variables, changes range in weight, the fault levels, success levels classification, training sample selection, and collection and processing of feedback data. And the stage 3, it is effective practice of mastering complex knowledge. And really, we have more than 40 realized problems by students. For example, fractal characteristic of lateral surface area of Schwarz cylinder, computer design, mathematical modeling in intellectual games, mathematical and computer modeling of fuzzy sets and fuzzy logic. And as an example, we can find the Schwarz cylinder as a fractal object. And it's Karl Hermann Schwarz, German mathematician, and let's consider a cylinder with height h and radius r. Example, the implementation of technological constructs of problem zone surface area based on the area's growth dynamics of multifaceted surfaces of cylinder lateral surface. Schwarz boot. Let's the regular Schwarz cylinder in the figure be such that it is divided into m equal height layers, and each layer is irregular and gone. In this case, all odd layers are rotated but an angle relative to the axis of a cylinder. And the surface area of Schwarz cylinder for different mn in infinity can take the Wöhler infinity. In this case, the polyhedral surface uniformly converges to the lateral surface of a cylinder. However, when m is more than n power 2, we have s is equal to infinity. This creates a problem zone for definition of surface area. And in this slide, you can see the tasks for updating the problem zone surface area for small groups. For example, computer modeling, mathematical modeling of finding the area of polyhedral surfaces, construction, calculation, properties, variations, laboratory and calculus classes. The existence and finding the surface area of smooth surface rotation around the axis. Computer and mathematical modeling of surface areas, finding of a sphere, corner, cylinder, torus, and finding the area of Schwarz cylinder surface in the regular case, different cases. And mathematical modeling and computer design we realized for special addiction. On the slide, and consider the bifurcation diagram in the following figure. And it is similar the Verhulst scenario in the study of surface area. We can remark when this picture concerned with Verhulst script for two bifurcations addiction, angle and blue line and area red line. And the surface, we can consider not only regular partitions of height, but irregular with next formula in this slide. And let's consider the surface area for m equals n to the power 2, and there are some difference between regular and or irregular case on the table. The potential students' activities can be realized with another formulas on the slide. We apply the method of Heighten or limits of growth by David Midlow for parameter n. Let's assume that the point moves along a circle, and in this case we will match the length of the segment ut to the central corner x and get the formula function f from x. And we have the ability to host the parameter n by direction of infinity according to a given formulas for broken line, 5, series sum. And we have a survey graph G from X as a fractal. And on this picture, we have original fractal surface, Schwarzkopf, consists from a survey of orthogonal cross sections of the layers. And similar results can be for cone or sphere, but cylinder and cone are linear surface 0, and sphere has Gaussian curvature 2. It will be so important to give every teacher the special information environment of artificial intelligence of each student's creative potential growth management. But we have some problems. To create and define the data base from holistic depository of modern achievements in science with stages of medical-computer symbiosis and ways of opportunities for adaptive local problems to school mathematics on the basis of reasonable selection criteria. Create of 5 neural networks according to architecture and functionality described above on the basis of 5 perception modalities. To give a psychological justification of chosen criteria for 9 parameters. And to determine of training sample for efficient operation of neural networks, 5 ELSA, and train neural networks, to define the technology and pedagogical support of students with such activity. Solving these important problems requires the joint efforts of mathematicians, computer scientists, educators, and psychologists. And thank you.